Hey guys, so on this lesson, we'll be learning about sequence. And sequence is an ordered list that follows a rule. So let me go ahead and put this in outline. So let's take a look at this one. And it says, so like the number of the term n, so like the first term, second term, third term, fourth term, it goes in the position of the value. So the first term goes with 3, second goes with 6, third, 9. So we have to take a look at what's the pattern on here. And so with the first number, if I write it again, just to take a look at this. With the first one, we have 3. With the second, we have 6. And okay, so far, I can already see a pattern. With the third one, we have 9. Can you guys guess what the fourth one is without looking? Um, fourth is 12, and then 5. I'm going to assume, right? Because if I take a look at a pattern from here to here, I'm multiplying by 3 every single time, or I'm adding 3, or add 3 from here. So I'm adding plus 3. So this would be 15, right? So that means that the sequence is the rule. We're going to recognize the sequence by AN. So this AN term is going to be 3 times the number n. So for example, if we have A4, 3 times 4 equals 12, right? So this fourth term right here, goes with this term, fourth, and they both equal the same, 12. So if we have the term A7, if I want to find the term A7, it's going to be 3 times 7, which is 21, right? Okay, so let's take a look at an example. And this example states that find the 8th and 9th terms of the sequence generated by the formula AN equals 3N. So this is the same one as we were working on before, right? The previous one. So if the 8th and the 9th terms corresponds to, so the 8th and 9th term, it means when n is equal to 8 and when n is equal to 9, then A, 8 is how you write it, is equal to 3, 8, which is equal to 3 times A is 24. And then A, when n equals 9, is A9 is equal to 3 times 9, which is equal to 27, right? So this would be A9, this would be A8. Make this look prettier. There you go. Okay, we can take a look at another one just to help you out with any work. Okay, so the next one says, find the next 2 terms in each sequence. So we're going to take a look at this problem. I'll label A in black, right? So it says, so A, oh no, that's not black. A is the first one. So A is in the sequence. The little brackets means the sequence. 2, 4, 8, 16. Okay, so I see a pattern. 32, dot, dot, dot. So if I see a pattern here, this term, 2 times 2 will give you 4. 4 times 2 will give you 8. 8 times 2 will give you 16. 16 times 2 will give you, that's the pattern that we're looking at. Okay, so let's take a look at B. B is 1, 1, 2, 3, 5, 8, dot, dot, dot. Okay, so here we can see that this, I add nothing, so I'm adding nothing. But this one, I'm adding 1. I'm adding another 1. I'm adding 2. And I'm adding 3. So in that case, then if we start from here, then if I don't mind this one, then from here to here, from 1 to 2, it's 1 plus 1. From 2 to 3, it's 2 plus 1, because I get 3. 2 plus 1 is 3. From here to here, it's 3 plus 2. From here to here, it's 5 plus 3. So each one, I'm adding one more from the previous one, right? Right, if we keep it going, then the next one would be 8 plus 4. And then, which is 13. And then 13 plus 5, which is 21, and so on. So, let's take a look at number C. We're just looking at a pattern here. We're not really looking for a rule. So C is 1, negative 2, 2, negative 1, 3, 0, 4, dot, dot, dot. So then, well, this one's kind of a little bit more. To get from 1 to negative 2, what I'm doing, I'm subtracting 3. And then, from here to here, to get from 2 to negative 2, I'm adding 4. And here, 2 to negative 1, I'm subtracting 3. And then I'm adding 4. Okay, so this is what we see. I'm subtracting 3, and then I'm adding 4, and that is our sequence. So it's minus 3 plus 4. Okay, so we did those. Take a look at another example. It says a rule for the sequence is in example 2a is an is equal to, or it's actually a sub n. So this a sub n, that's how you read it, a sub n is equal to 2n. So then it's asking us to find the 10th term in the sequence. So the first term, what that means is the first term in the sequence corresponds to n equals 1. So then the 10th term, can you guys guess what it is? Will respond to n equals 10. So that's what it's asking for us. It's asking what is an when n equals 10? So then if I grab, so the rule is an equals 2n. So when a equals 10, n equals 10, then to the n. That's what that means. You can just leave it like that if you wish. Okay, let's take a look at another example. Just one more after this. Okay, so find the first 3 terms of the sequence given by the formula. So our first one is, so our formula is an equals 1 plus 2n. That's what our formula is. So to find the first 3 terms, that means we're going to have to find n equals 1, n equals 2, and n equals 3. Those are the first 3 terms. So, oh, I don't know how to do it. Those are the first 3 terms. So then this is when a1 is equal to 1 plus 2, and then I plug in 1 for n. And then, so then this would equal 1 plus 3 is equal to 4. So then for our second term, I'm just going to write it. 1 plus 2, 2. And you guys can solve it while I'm doing it. A3 is 1 plus 2, and then I'll plug in 3 for whatever n is. So it's 1 plus 4 is equal to 5. And then 1 plus 6 is equal to 7. So then this is our answer for A1, A2, and A3. Those are our first three terms. Pretty simple, right, when we have the formula? So our next example is, it says this. The numbers in the sequence are sometimes called triangular numbers. So we have the sequence, it gives us 1, 3, 6, 10, 15, dot, 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 so on, right? These numbers of objects can be arranged in triangular patterns. Triangular numbers can be found using this formula. So AN, I'm going to write it up here. AN is equal to N times N plus 1 all over 2, right? So it's asking us to find the 10th triangular member. So what that means is we're going to use the formula, this one, to find what? N is equal to 10. So then we plug it in. It's going to, A10 is equal to N, when N is 10, 10 plus, that's ugly, plus 1 all over 2. So let's go ahead and simplify that then. So it's going to be 10 over 10 plus 1 is 11 over 2, which is equal to 10 times 11 is 110 over 2, which is 55. So when A10, it is 55. Don't know how to make pretty squares. There you go. Awesome. Okay, so now this is a problem on your lesson practice. So this is the first problem, actually. So this is the first problem on lesson practice. So it gives us, what is the 7th term of the sequence? So our first term, we have this 1, 4, 9, 16, dot, 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 right? And I can go ahead and put this. This means that it goes on. It doesn't stop there. So let's take a look at a pattern. So if I add, this one adds 3 and this one adds 5, and then this one like adds 7. So it could go on. And 3, 5, 7, those are odd numbers. But there's another problem. How do we know that the next one will definitely be plus 9? So if I take a look at this again without doing adding, I can also see that the first sequence is 1. The second sequence, so when A equals 1, it's 1. A is 2 is 4. A is 3 is 9. I can also see that these are squared numbers. These are squared numbers. Do you guys remember what that is? So squared numbers are if I square, you know, like 1 squared is equal 1 times 1, right? That equals 1. 2 squared is the same thing as saying 2 times 2, which is 4. 3 squared is 3 times 3, which equals 9, right? So then the sequence, it would be written as, so the rule, I can put rule is an equals n squared, right? So it's asking us to find the 7th sequence. So it's saying when a is 7, what is it? So I just plug in 7, and that gives you 49. That's it. And we are done.